Okay, good morning. I hope that you guys had a good weekend. I really need you guys to focus and all of the talking and laughing and joking. I need you to really bring it down a notch, okay? Because we have this week left of new topics to learn, and then you're going to have your review and your CDA next week. Okay, that is a CDA, the one that you take on the computers. That is going in the grade book as well as your quizzes that you've taken. So it's time out for all the laughing and joking. You've had your fun. I really need you guys to settle down and stop talking. So I need you to pay attention so that you'll have some good scores. Please don't forget the class competition, the class that is the best behaved, that has the least amount of write-ups or referrals to an administrator, and the class that has the highest average, meaning a passing average, it must be 70 or above, on your classwork and your CDA will get a pizza party. Now, I'm not going to give a pizza party to a class who's being disruptive and laughing and talking, okay? So I've already called some parents. I will continue to call parents, and we will not have a good Christmas because I will keep calling so long as you misbehave. Okay, so now that we've got that taken care of, we need to remember how we find the rate of change. Remember that rate of change is the same thing as slope. So if you don't remember the formula, the slope formula is y2 minus y1 over x2 minus x1. So in order to use this formula, you need 2 points. Now, they don't always give you your points written out like this. Sometimes they will. Sometimes they don't. If they give you a word problem or what we call application problem, they'll give you the 2 points, but they won't be set up with a parenthesis. They're going to give it to you as an x value and a y value, and you have to figure that out from the word problem. Remember, the other way that we can find the slope or the rate of change is if we have a graph, we can do rise over run. Okay, so let's look at our first example for our warm-up. They say for f of x equals negative 7x plus 2, they want you to find the rate of change on the interval of 4 to 10. Now, we have to remember that whenever they give me two numbers inside of brackets, they're giving me two x values. This is going to be my first x value. This is going to be my second x value because of these brackets that are right here, okay? Anytime they give you two numbers in brackets, they're giving you x values. So in order to find the y values, we have to plug in each one of our x values into this function. Okay, now you didn't have any problems like this on your worksheet. That's why I'm presenting them today, because you will see a problem like this on your CDA. So I'm just going to plug in the first value of x into the problem. So I'm going to go down here simply because I need some space, but you can write this underneath your problem number 1, okay? So we're going to do f of 4. And notice I put the 4 inside of parentheses because x is my input. Input is what we're going to put in. So that means everywhere I see an x at the top, which is right here, we're going to replace it with a 4 because we're using the first x value first, okay? So the 4 goes in plus 2. All right, and then we will repeat the process. This time, we're going to plug in the second x value, which is a 10. So I'm going to say f of 10 equals, I'm going to write this function just like we did when we were evaluating functions. But everywhere I see an x, I get to plug in the number 10 since that is my input value over here. Okay, so that's negative 7 times 10 plus 2. Now what we get out of here is our output or our y value. Remember, y is the output, x is the input. So negative 7 times 4 gives me a negative 28. And then if I add 2 to that, since the signs are different, I actually subtract and I get negative 26. So So up here, I'm going to write my first point. The x value, which is what we put in, was 4. And the y value, which was my output, or f of x here, remember they're the same thing, my output was negative 26. So when I put in 4, I got a negative 26 out. Now I have to do it for my second point. So this point, our input is going to be 10, because that is what we're putting in. This is my x value. And what do we get out? So negative 7 times 10 is going to give me negative 70. Plus 2 will give me a negative 68, because we end up subtracting. So now I did all of that work just so I could get these 2 points. Okay? Because we cannot find the slope until we have 2 points. And I just found my 2 points right there. Okay? Now we're ready to come over here and use the slope formula in order to find our rate of change. And remember, rate of change is the same thing as slope. So I'm going to be doing my slope formula here. This is the formula I'm using because we're talking about our rate of change, which is the same thing as slope. And I always use this formula when I'm given 2 points. And we were given enough information to get 2 points here. Alright, so now I'm going to find the rate of change using the 2 points that we just found. So remember, the first number is x, the second one is a y. These get little ones because they are the first point. The second value is an x, and this one is a y. And these will get the little 2's because they are the second point. So the 2 numbers I'm subtracting on the top, it says y2, negative 68, minus y1, which is negative 26. Remember when we learned this, that if your number is negative, it gets its own negative because the formula has a subtraction sign that has to show up in your problem where you write it. Alright, so that's our y values on the top. Then we're going to do the x's on the bottom. So it says x2, we labeled 10 x2, so that's going to go first, minus x1, which is 4. Alright, now we can subtract. Now remember, every time that we see double negatives, we make it one big plus sign. So that means we're actually doing negative 28 plus 26. And since the signs are different, we are subtracting the numbers. So we get negative 42 on the top. And on the bottom, 10 minus 4 gives me 6. And remember, you always have to simplify your slope. You will not be able to find the correct answer on your CDA if you do not simplify it. So simplifying is negative 42 divided by 6, because that's what a fraction bar means. We get the number negative 7. And make sure you write that down correct. That is a negative 7. Okay? I'm trying to make my little negative stick out a little bit here. So that's negative and then a 7. Okay, so that is the rate of change. Notice what we had to do to get this answer. We had to take the 2 x values, plug them in to get the y values that we saw down here. Then we wrote a point with one number from the x and one number from the y. Then we used our slope formula and we simplified our answer. Now that is probably as difficult as I can make this problem. Okay, I think you only have one of those on your CDA. But I wanted to make sure that we went over it together. Alright, now let's move on to number 2. I am going to clear my work from the bottom of the board. I'll leave the one at the top in case you need to copy that down. Alright, for number 2, that gave me a word problem. So my goal, because I see the word rate of change, my goal is to find the 2 points that I'm going to be using to create my slope formula. Okay? So in 2009, I weighed 205 pounds. And now I weigh 150 pounds. This is a true story. So what is the rate of change in my weight per year? So in order to do this, we're going to have to find the slope. The rate of change is going to represent how much weight I lost per year. And you can say I lost weight because you see I started out at 205 and now I'm 150. So obviously my weight went down. Alright, so what should we use for our first point? Alright, if you put 2009 as your first X value, and the amount that I weighed in 2009, which is 205 pounds, if you wrote this as your first point, you were correct. Now, what would my second point be? This year is 2016. And notice I said, and now, so now would have to be the current year. I weigh 150 pounds. Okay? So those are my 2 points. I have 2009 and 205, 2016 and 150 as my 2 points. Now I can set up my formula. We're going to subtract the Y's on the top, and we will subtract the X's on the bottom. Alright, everybody should be paying attention because this is how you see these problems on your CDA that you are taking next week. Okay, next Wednesday and Thursday will be our CDA days, and it will be on what you've learned here with Miss Hall. Okay, and that is going into the grade book. Of course, there will not be any makeups because you'll be on Christmas break. Alright, so I'm going to label my points. So this is my X1. This is Y1, this is X2, and this will be Y2. Alright, so we're subtracting the Y's on the top, so I put 150 minus 205 divided by 2016, because that's X2, minus X1, which is 2009. Alright, and this is going to tell me how much weight I lost per year because 2016 and 2009 are years. So when we subtract 150 minus 205, we get 55. So that shows you the total amount of weight that I lost. Then when we subtract the bottom, which is 2016 minus 2009, we get 7. Now I know that 7 does not go in 55 evenly, but I would like to see my answer, rounded to one place behind the decimal. Okay, so I'm going to put in my calculator 55 divided by 7, and we're going to keep one place behind the decimal. So this equals, I guess I'll put it right here, 7.9, and I did round that 9 pounds per year, and that should be negative. The 55 should have been negative, and this would be negative 7.9. Okay, it's important that it's negative because remember we subtracted 205 from 150, and you're going to get a negative number when you take a bigger number from a smaller number. And remember, we also talked about how my weight went down in the beginning. So in order to indicate that it went down in this word problem, I have to have this negative. So I lost about 8 pounds per year. Okay? And that is my rate of change. This is also called a unit rate of change because it tells you how much I lost for every 1 year. Okay? Now we're going to look at number 3. And in order to look at number 3, I need to clear the board. So if you need to copy any of this stuff down that's up here, Miss Hall, would you please pause the video right now? If not, I'm going to go ahead and clear. All right, so number 3 is going to use the chart that we have over here right next to it, okay? So what I'm asking you is the rate of change positive, negative, 0, or undefined? All right, positive, negative, 0, or undefined. Now, whenever you have a graph, you don't have to do all the find the points thing. You don't need an X and a Y. You don't have to use 2 points. You can, if you like using the formula, you can write down the points, but I'm going to show you the alternative method that we learn to use every time we have a graph. So from A to B, A is located down here. So I'm going to put a dot there, and B is located right here. So you do have problems like this on your CDA that will ask you to find a rate of change from one value to the next, but they don't use A and B. They may say from the X value of 0 to the X value of 10. So 0, of course, would be where A is, and B would be where 10 is, because it lines up with the 10, okay? So we're just going to do rise over run. Now, when you do rise over run, you have to pay attention to how your axes are labeled. These are labeled in tens, and the little marks in between represent 5. So we have to make sure as we count, we're not counting 1, 2, 3, 4, 5. We're counting 10, 20, 30, 40, and so on, okay? The x-axis is also in tens because it goes 10, 20, 30, 40, and 50. So we have to use those type of increments when we count this out. All right, so remember we're going to do rise. So we're going to go straight up first, and then we'll do run. So you got to tell me how many units you had to go up first. That's going to be the top of my fraction. And then we'll do run on the side. So we're using rise over run. Okay, so we had to rise 50. So 50 goes on the top. And we had to run 10 because that's how many units we moved over. 10. Okay, and that will simplify to the number 5. Okay, so is that a positive or a negative or a 0 slope? That represents a positive slope because the number is positive. You can also look at the line. If you trace the line starting at the left side of your line to the right side, notice when I draw this line, I'm going up. So that would represent a positive slope. A negative slope would go down as you trace it from left to right. And 0 slope, remember, is like the 0 line. So it's going to go straight across. And an undefined line will go straight up and down. All right? So let me clear what I wrote on this graph because we're going to do another one. And this slope was 5, so that meant it was positive. Okay, now let's look at the slope from B to C. Alright, so now I want to do rise over run again. Excuse my phone, I'm getting messages from the principal. Okay, alright, so rise, do I have to go up or down to get from B to C? I don't have to do either, so that means that number is going to be 0. Now my run, remember every 2 marks that we move is 10. So that means they're going by 5s. So this is 5, 10, 15. So I have 0 over 15, which is 0. So my slope is 0, which means this is a 0 slope. Also look at the line. Anytime your line goes straight across side to side, your slope is going to be 0. Alright, so let me clear this off. Alright, and let's look at from C to D. Alright, so if I do rise over run, we're counting how many units I have to go up, starting at D to get to C. And notice this time that we are running to the left. So I'm still using rise over run. Alright, remember every time we jump, we're jumping in 5s because our graph over here goes 5, 10, 10, 15, 20, and the line in between is 25. So each box represents a 5. So here we go. 5, 10, 15, 20, 25, 30. So 30 is going to be my top box. My top number. And then we have to run over 1, and one box on this graph represents 5, but it's going to be a -5 because we went to the left. And moving to the left represents a negative direction, okay? Now we have to simplify, so this is going to give me -6. So the slope from C to D is -6, which of course means that it is moving in a negative direction. Now, without even finding the slope, how else do you think you could identify that this slope was going to be negative? Correct. All you have to do is trace the line. So if I start on the left side of the line, going from C to D, this would be the left side, and we move to the right, we are moving in a downward direction. Down means negative. Up, like we did from A to B, means that we're moving in a positive direction. Okay? Alright, now we need to find the slope from D to E. So let me clear off what I have over here. Alright, so we're looking at just from D to E, which is this point right here. Let me change my color so everybody can see. So rise over run. In order to rise, you have to start at the lower point, and we're going straight up. So how many do I have to go up in order to get in line with E? Remember, each box is 5, so that's 5, 10. So 10 is my rise number, and 10 is positive because going up is a positive direction. Now we're going to run, and we're going to run to the right, which is also a positive direction. So let's count the cubes we have to jump. 5, 10, 15. So 15 would go at the bottom. Now we need to simplify this fraction. You can put it in your calculator as 10 divided by 15, which will give you a decimal, and then hit math, enter to turn it back into the simplified slope, the simplified fraction, which would be 2 over 3. So my slope is 2 over 3. And just by looking at the line, would you say this line is going up or going down? This line is going up as we look at it from left to right, which means this is a positive slope. We can also tell it's positive because our slope, the number 2 over 3, is a positive number. Alright, we have one more to do, and then we will be done with our review warm-up. So the lesson today is going to be a review on rate of change to make sure that you've got this before you go to your CDA. You probably have about 6 or 7 problems that are just rate of change. Alright, we're not done, so let's focus, please. We're going from E to F. So E to F. Now remember, we do rise. So I'm going to count how many spaces I have to move up first, and then I do the side to side number on the bottom. So let's count our blocks. 5, 10, 15, 20, 25. So we have 25. Well, actually this graph is misnumbered at the bottom, so they don't start counting by 5s until they get to 10. So we're going to have to use the number that's over here to count this out correctly, because we dropped from the bottom to the top. It lines up with 30. So we went up 30. Now normally I would do by 5s, but this is an example of a graph that is misleading because they did not put the extra block like they did on the x-axis. They put a mark for 5 here. They did not do that on this axis, so that threw us off. Alright, now let's do our run. So all of our x-axis are labeled where each tick mark is 5. So each block is 5, and look which way we ran, to the left. So that is a -5, and so my slope is a -6. And of course, because it's negative, it has a negative slope, and we can also tell that by just looking at the graph. I can look and see which direction it is going, and it's going down. All right, so if this is Tuesday, December the 6th, is odd class, your CDA is going to be next Wednesday. And if this is 12/7, which is my even classes, your CDA is going to be next Thursday. Okay? So today we're going to review rate of change, which means you're going to be using your slope formula, rise over run if you see a graph, the slope formula if you're given 2 points. Okay? And then we will move on to something else in the next class. Okay? And that will be the last new item that we will be learning for this CDA. So please be on your best behavior. I hope I don't have to call anybody today. You guys know what I expect from you. Please make sure you're getting your work done. Grades are being updated. Your last CDA scores are in the grade book, so if you would like to see what you made, you can go ahead and do that. All of the rock stars and mathematicians will get their awards when I come back. All right? Thank you.